to use the formula versus just coming up with it on our own like we've been doing. But it's important to know how to use conditional probability without a formula. That's the foundation. The formula is just a shortcut. So we're going to develop the formula today for conditional probability, and we're going to use it. We're going to develop it, and we're going to use it. So it says we've calculated conditional probabilities using counts. We did that with counts Venn diagrams yesterday and counts frequency tables yesterday. You can develop a formula to find conditional probability given probabilities. Begin with a Venn diagram showing counts. So this one is a counts Venn diagram. You should recognize it because it's the same, one of the same ones that we did yesterday, the Cocoa Wildlife Preserve. And we have tortoises and animals of known gender. So it says the relevant counts are given in this Venn diagram. T is the set of tortoises, K is the set of animals of known gender. It's the same exact one from yesterday, same numbers and everything. And so number one, it says to write each probability as a fraction. So first of all, we need to find the probability of T given K. So remember, the given information is the K. K is the known gender. So the probability of known gender would be, or the counts of known gender is how many? 57. And then the numerator has to be probability of T and K. So T and K is what number? 20. The 20. The and is the overlap. So it's 20 out of 57. Now let's look at just T and K. Probability of just T and K. Well, what number represents the and? 20. 20. And we need to put it out of the total because it's not a given, it's not a conditional probability. When it's not conditional, that means it's out of the total. How can I find the total? Adding up all the numbers. Does anyone remember what this total is? 91. 4 plus 20 plus 37 plus 30 adds up to 91. So it is 20 out of 91. Okay? And then the probability of just K means it's not conditional because there's no given bar. So it's just also going to be, oops, I wrote 90, not 91. So it's going to also be out of 91. And how many are in the known gender bubble? 57. 57. So it's 57 out of 91. Okay. So we've got those three fractions there representing three different probabilities. And it says in letter D to calculate the probability of T and K over the probability of K. And what do we notice? So we have to notice something. So the probability of T and K, that was found in part B. It's 20 over 91. Over the probability of just K, we found that in part C, was 57 over 91. So it's just like the homework, that situation where we got a ton of fraction bars. We have to switch the middle fraction bar to the divide symbol, but I'm going to skip that step. We're going to go ahead and flip the second and multiply. So that'll be 20 over 91 times, because we're going to flip the second fraction and multiply, is 91 over 57. And then what happens? The 91s cancel, right. So then all we have left is 20 out of, I don't know why I wrote 51. That should be a 57, right?
Yeah.
20 out of 57. And now, do we notice something?
Is this same as B?
It's the same as part A. Same as A. Okay. A was the probability of T given K. Well, based on yesterday, when we're finding probabilities, don't we have to find the probability of K and put that in the denominator? And then the probability of T and K and put that in the numerator? So by definition, these two are equivalent. Thank you. Did you send to Natalie? Thank you. Okay. So we already knew that going in. We just needed to recognize that again because that's definitely something we need to understand that's happening here. So that's what leads us to the formula. It's simply what we've already been doing. It's really nothing new. It's just now we could be like, oh, it's a formula. So it says for any two events A and B, the probability of A given B is the probability of A and B divided by the probability of B. Remember, the given information always goes in the denominator. The numerator is always both events. It's the and. Okay? All right, turn the page. So it's really nothing new. Well, so far, nothing new. Because you already did that yesterday. You just didn't know it was a formula. We were just doing it. Okay? So now it says, do you think the likelihood of the animal being a tortoise depends on whether the gender of the animal is known? Does the animal being a tortoise depend on knowing its gender? Does any animal, being whatever animal it is, depend on what its gender is? No, male or female doesn't make it a tortoise. Male or female doesn't make it a dog. Male or female doesn't make it a cat. So then it doesn't depend on gender, does it? So let's put, no it doesn't. Now this one's easy to answer because we just used some common sense to answer that. We didn't have to use math for that. We just know based on gender and animals that being male or female doesn't determine what kind of an animal you are. Okay? So let's put gender doesn't determine the type of animal. So this one was easy to tell that the events are not dependent upon each other. But there's going to be times where two events are going to be not so easy to tell if they're dependent or not. So there's got to be another way, and there is. It's using the formula that we just generated. So it says that suppose A and B are dependent events. Suppose they are dependent. Write a formula for the probability of A and B by rearranging the conditional probability formula. So before we do that though, let's talk about what dependent events are. Two events are said to be dependent if the result of the second event is affected by the result of the first event. If one event affects the outcome of the other event, then they're considered dependent on each other. Now, in number 2's case, gender does not affect what type of animal an animal is going to be. Okay, genetics does, not gender. Okay, but it won't always be plain and simple, black and white like that. Okay, so we are going to do it. It says we're going to write a formula for the probability of A and B. It says by rearranging the conditional probability formula. That was from the bottom of the last page, the formula that we boxed. That formula was probability of A given B equals probability of A and B over probability of B. That was the formula. They want us to rearrange it, and they want us to rearrange it for probability of A and B. So they want the probability of A and B, this numerator right here, they want this all by itself on one side of the equal sign. Which means we got to get rid of that probability of B. It's in the denominator. How do I get rid of it? Multiply it, right? The opposite of division is multiplication. So we got to multiply both sides by the probability of B. So we can get this to go away. So then we're going to have, I'll flip this around, the probability of A and B equals the probability of B times the probability of A given B. So basically this is another variation of the formula that we got on the last page, but it only works for what kind of events? Dependent events. They have to be dependent upon each other. So we're going to learn how to test for dependence today also. So it says the reasoning above leads to what is called the multiplication rule for dependent events. So again, they've got to be dependent events. So if A and B are dependent, then the probability of A and B equals the probability of B times the probability of A given B. Okay, and I'll show you how to use that formula. So we're going to do the check your understanding number 4 down here. And it says the Cocoa Foundation takes care of a number of primates. When a primate is selected at random, let T be the event that it is tamarin, and let N be the event that it is at least 9 years old. Some of the relevant probabilities are shown in the Venn diagram. So is this a probabilities Venn diagram?
Yes.
Yeah, we've got decimals this time. So this is not a counts. This is a probabilities Venn diagram. So the probabilities have already been calculated. Okay? So for A, B, and C, it says write your answer to each question using probability notation. There's like no room to work here, so I'm gonna put A, B, and C's answers over here on this left-hand side. Start with A up there. It says, what is the probability that a randomly selected primate is a tamarin and at least 9 years old? Where's the and section? The middle, right, the 0.27. So using the probability notation, it would go probability of T and N, tamarin and at least 9 years old, equals 0.27. So 27% chance of selecting a primate that is both tamarin and at least 9 years old. Okay, so that was part A. That was pretty simple. You just had to look at the Venn diagram. Letter B says, what is the probability that a randomly selected primate is at least 9 years old? So this is just one event. So what letter are we using for at least 9 years old? N. So probability of N. And how can I find that total? Add the 0.21 and the 0.27. Everything in the N bubble. What does that add up to? 0.48. Okay. Again, that wasn't bad. We're just adding, looking at our Venn diagram and having to add. Letter C, it says, what is the probability that a randomly selected primate is tamarin given that it is at least 9 years old? So tamarin given at least 9 years old. And I'm going to stop there. There's another question after that, but let's find this first. So using probability notation, it's probability of something given something. What letter goes first? T, and then what? N. Given that's at least 9 years old. So the 9 years old has to come last. So we learned how to do this. We know that there's a formula also. Well, we know that the given information goes in the denominator. So we don't really need this formula because we know that the given information is in the bottom and then the and section is in the top. So what's the probability of N? 0.48. We just found that in part B. What's the probability of T and N? 0.27. So now we need our calculator, and let's round this to the nearest hundredth. 0.27 divided by 0.48. So to the nearest hundredth, what should I write? 0.56. So the probability of T and N is 0.56. So we answered the first question to part C. Then it says, are the events dependent? It says to use the probability formula. So the formula they want us to test out is this one. Because if they are dependent, won't this be true? Yeah. So this is our test. So we need to do a dependent test. Dependent test. So for our dependent test, we have to use the letters T and N instead of A's and B's. So it will go probability of T and N equals the probability of the second letter, so probability of N times the probability of T given N. Okay, we need to verify that this is going to be true. If it's true, then they're dependent. If it's not true, then they're not dependent. What's the opposite of dependent? Independent, right. So it would be the opposite. All right, so probability of T and N, don't we know what that is? 0.27, right. So 0.27 equals, do we know the probability of N? 0.48, right? We'll put that in parentheses to signify multiplication. Probability of T given N, do we know what that is? 0.56. So I'm going to put a question mark over that equal sign because we're trying to see if this is true. So basically, I need to see if 0.48 times 0.56 is going to be 0.27. 0.48 times 0.56 Is that going to round to 0.27?
Yeah.
Yeah, it does. So it checks out. So that means these are dependent events. Are dependent. If I did not get a true mathematical statement, then I would say they are not dependent. Okay? So that formula right here, this multiplication rule, what it's going to do is it's going to be your dependent test. It's going to help you figure out if two events are dependent or not. So the two events being Tamarin and at least 9 years old are dependent upon each other in this situation. Okay? All right, go ahead and turn the page. And that was it. That was fast. All right, so we have like 15-ish minutes left, more than 15-ish minutes left. Go ahead and open up your Chromebooks, go to Google Classroom, and you'll find the PDF for 28.2. You're doing numbers 81 through 90. Let me get you guys a new homework record. Yeah, if you guys ever need paper, there's some of that back table also. Go ahead and get started on the homework. You might even be able to finish it. So we just turned in record 6, so this is record number 7. And I heard yesterday that we've got 36 school days left. Doesn't that sound really short? Like, whoa, how did we get that far so fast? And that's why I'm so confused, right? Because even my kids really like Minecraft, and I'm like, I never got into Minecraft. It's an old game. My husband did, but when he was a kid, but me, I was like, I didn't care for it. But my kids love Minecraft. I like building stuff.
Wait, what homework record is this?
This is number 7. Number 7.
Just ages.
It is. They like building rooms and houses and be like, someday my house is gonna be just like this. And I'm like, okay, a pool in your basement? You know? That makes sense.
What's wrong with the pool in the basement?
Well, if you live in places like Tennessee, that probably wouldn't be a good idea.
You just swim through the pool.
Swim through a tornado? I think of drowning in a tornado, you're trapped under there, you know? They were under a tornado watch last week.
I don't know.
Insane. It was pretty bad. And now, like the east side, like Minnesota, our friends from Minnesota, they're under a ton of snow. Their school got canceled this week because of snow. But they get like, we get inches, sometimes half an inch to 2 inches normally. They get feet. They get feet of snow. So it makes sense why they get a snow day and we don't. Oh my gosh, I forgot to